All right, it's 10 a.m. Let's get started. Good morning, everyone. Welcome to Long Coffee Break. My name is Sean Davenport Smith. Today, we're going to be talking about Lync Aegis heat pump water heaters. My co-host today is Brian Cummings. He's with Watts, and I'll hand it on over to him. Thanks, Brian.
Awesome. Thanks, Sean. So my name is Brian Cummings. I'm the regional sales manager now for the Lync heat pump. Previously, I was a product manager. I'm actually based here in Denver, so it's nice to do presentations locally as well. I think everybody on this call knows about climate initiatives and what we have going on in Denver and in Colorado and other places, but I wanted to highlight we're seeing a large change in this now because we've been talking about this for years. And, the Denver codes have gotten pushed off a little bit, but this is happening in places now. In Massachusetts, you're required to use heat pumps, various other equipment on jobs. In Seattle, everything has to be electric. So we're seeing a massive difference in equipment that's out there and interest from engineers and stuff. And so this information is just becoming more and more required for doing the engineering work that we do. Real briefly, I know most of you probably know this already, but I want to make sure we're all on the same page here. The idea of a heat pump is it's moving energy from one area to another. So we're able to capture energy, low quality energy, at say the outdoor air temperature of 40 degrees this morning. We run it through our unit, we take some energy out, it comes out of there at 30 degrees, and we add some electricity into the unit, and we're able to get domestic hot water at 140 degrees out of this unit. The key here is we are only paying for the electrical energy in these systems. The thermal energy is coming from outdoors, which is a free source. And the total energy that we get out is therefore more than the electrical that we put in. And that's a big deal with these because it's going to look like we're more than 100% efficient. With gas or electricity, you can only hit 100% efficiency. And with heat pumps, you can hit higher efficiencies. That's why we talk about coefficient of performance. Coefficient of performance is 2. It's saying we're getting twice the energy out that we put in. And that means we're about 200% efficient. And this is why heat pumps are on the cutting edge right now, why people are talking about them, because it's more energy efficient than any other means of capturing energy out there. Our product is called Aegis. It's designed for heating domestic hot water. Couple key points about it. We use carbon dioxide as the refrigerant. Now, we talk a lot of times about carbon dioxide being damaging to the environment, but its global warming potential is significantly less than the chemical refrigerants that are used out there today. Its global warming potential is 1, and the chemical refrigerants can be up to 2,000 times worse. So it's a very clean refrigerant. We focus on commercial buildings and commercial needs, not residential. This is heavy duty equipment intended to work 24/7 or whatever needs are for commercial buildings. Our sizes, we have 3 sizes between 250 and 500,000 BTUs an hour. Now, if you're used to water heaters on buildings, a lot of times they're larger than that. We have to shift the paradigm. We have to look at this differently because the technology is different than the water heaters we have. So for cost reasons and overall impact to the job, we have less power, but we have more storage on the jobs. We have both water and air source heat pumps. So the one I demonstrated in the previous slide is an air source. It's grabbing its thermal energy from the air. A water source is going to use something like a chiller loop, or if you've ever been to the IKEA, they have boreholes drilled in the ground and it pulls energy out of the ground to provide the heating for that building. So it's just where it's getting that source energy from. We operate down to 4 degrees below zero. So within here, you have to boil the refrigerant, and there's kind of a minimum point that you can do this. We actually advertise -4 because we have an environmental chamber that we've tested in, and that's as cold as we can get it. We are working at building a new environmental chamber in Texas that'll get us down to at least -20 degrees, so that we can begin to test these at colder temperatures. Obviously, this is a key thing here in Colorado, and we'll talk more about it here in a minute. One of the key reasons to go with carbon dioxide is that we can hit very high temperatures. If it is 4 degrees below zero outside, and I think from earlier in the week, we all remember how bad those temperatures are and how cold it is. Even when it's that cold outside, we can still hit 170 degrees on our hot water temperature. This means we can reduce our storage volumes and other things within our system. That's an advantage. And that's one of the big reasons to use carbon dioxide as a refrigerant. The other thing is we have the highest yearly average coefficient of performance of any refrigerant used for heating hot water out there. And that's the big driver for this, is that the performance is very good. There are a lot of people coming out with heat pumps now. AHR is next week. And last year, I think there was 5 different heat pumps that were debuted at AHR for water heating. And I'm sure there'll be double that number this year. One of the things that we want to offer, and you know, the Watts brands in general, whether it be Airco or PVI, is really proven technology. We sourced this unit. We partnered with a company in Italy called Enerblue, and we've done a lot of testing on these units in order to ensure that they're going to work properly. So the compressor that we use has been in production for over 10 years. The heat pump that we use, the basic models of it used in Europe and in Scandinavian countries, started in 2015, so it's 9 years in production. We also provide the system with it, all the tanks and other things that you need within the system to make it work. And because of that, we have to do extensive testing. It isn't just a matter of the heat pump itself working, the entire system has to work well together. So Enerblue in Italy has an environmental chamber, and I was over there, I don't know, 4 times last year, testing the units in the environmental chamber to make sure that the changes that we made to them work properly and stuff. That's the picture on the left. The picture on the right is our lab in Texas. We test everything we can in the United States and then bring it over to Italy. So, you know, we have a really proven technology. We've invested heavily in this and believe that this is the future. Now, going back to the lower temperature is somewhat dependent on the refrigerant that you choose. So R134A, common refrigerant today, is getting phased out. There's very little areas. It goes down to about 30 degrees is where it can operate. So if you're not in one of these areas of the country, you're going to freeze. And you're going to have full backup in that case. So here, because of all the colder temperatures, it's not the best refrigerant. We come to its replacement, R513 and some R410 units, which are on the market today. It does encompass a larger portion of the country. These go down to about 10 degrees Fahrenheit, and you can see you expand it. When we do things with the CO2, we cover a much larger portion of the country. And one of the issues with hot water is, of course, you have to have it regardless of the outside air conditions. And, you know, this week we experienced temperatures down below that -4 that we operate. So we need to have backups and stuff in Denver. But we cover a wider range. And hopefully in another year or so, I'll be coming back and presenting to everybody and saying, yeah, we can go down to -20, but we want to actually run the equipment down to that temperature. And unfortunately, there's very few places, environmental chambers in the US or Europe, that you can do that work in. So we're building our own so that we can prove this technology out. One of the key things we need to talk about with heat pumps is overall savings from the system. Okay, people are going to start doing this because the code dictates that they have to, and that's coming in 2 years from now, or who knows, because they've delayed it and changed it and many different things. But there are additional savings you get from these units. So if you take one of our smaller units in a properly sized system for apartments, we save about 220,000 kilowatt hours per year versus electric. Now, a lot of times in Colorado, we're going to have gas fired. So what's the savings? Yeah, we're going to save energy-wise, but dollar-wise, it's so cheap for natural gas. You have to be comparing this to electric and electric initiatives. Otherwise, it's not going to make sense. But we take that 220,000 kilowatt hours and we convert that to money, which is about 12 cents a kilowatt hour. Denver on commercial runs about here for electrical rates. They've kind of been volatile in the past couple of years. But it's about 25,000 a year in savings. A lot of clients are looking at how much carbon dioxide you're saving from emissions. And again, versus electric, you're looking at about 200,000 pounds per unit. And of course, this scales upwards as you put more units on the system. So this is a very key thing with our equipment, is the savings that we provide. It's a very real savings that heat pumps provide to buildings and designs. Another key thing about heat pumps is we want to be involved from very early on in the process. Heat pump system kind of breaks apart a water heater. Instead of having everything in one unit, we have to have our heat pump outdoors. We have to have a means of transferring that energy to our tanks. We have to have a backup system, or a system that at least covers the recirculation losses, and then the recirculation loop and delivery to the building. So it's very important that all these things work properly together. And that's one big thing that we offer as Lync. We partnered with a company in Europe that custom designed a unit for us for the US market. And we manufacture all the other pieces within this system. That means we're going to offer you support on everything that you see within the system. If there's a problem, it's our fault, and we'll take care of it. It's not a matter of pointing fingers where someone provides the tanks, someone else provides a mixing valve, and they don't work right together and stuff. These systems are more sensitive. There's a lot more things going on in them than a typical hot water heater, and we need to make sure that they work properly. So, regardless if it's our system or someone else's, just make sure that you're having somebody who's responsible for the entire thing, because there's a lot of things that could go wrong in these systems. So, we'll help you from beginning to end, design this, commission it, whatever we need to do. I'll highlight some of the installations that we have across the country. We are up to about 50 units which are being installed. This one here is in Hudson Yards in New York City. It's water source units running off a chiller loop for Facebook there. Does a kitchen. We have stuff in the Pacific Northwest. A lot of these states that are highlighted where we have things have the electrification initiatives that are more advanced. So all these different systems that are out there. This is Moderna in Cambridge, Massachusetts. It's a total of 6 units on the building to do 3 different hot water systems for them. Oregon State University, some apartments in New York. We have a system here in Phoenix at the Four Seasons Hotel. This is, again, a water source that runs off the chiller loop and provides heat for the hotel as well as the kitchens and stuff there. We have a number of systems in California, the DC area, Vancouver, British Columbia. We have a system here. This is on a pool. We have several more that are commissioned. This is the first one we commissioned about 2 years ago. This does the showers and the bathrooms for the pool. We have a whole bunch again in New York City. This is one of the housing projects there. And again, we provide all the equipment, all the solutions that you need on these systems. Florida, here's one where there's obviously no electrification initiatives, but the company, SpaceX, wanted to be green, so they put a system on there. This is a hotel in the Bay Area here, where we have a couple units heating the water for the hotel. So as you can see, we have quite a number of installations, quite a large track record coming into this. We've had good success with these systems, and we're able to provide all the help that you guys need in order to make these things successful. So thank you very much for your time, and I'll pass it back off to Sean here to talk about the prizes today.
Yeah, thanks a lot, Brian. A couple of points I want to point out there is one of your first maps that showed the electrical initiatives per state, but also showed installations, and it showed just as many installations going into states that don't have initiatives. So this is really an owner-driven thing as well as initiative-driven. And no matter what job, where you're working on it, you could potentially be working with a heat pump water heater. Also, if you are making it out to AHR next week, please do stop by the Watts booth to see this in person. Please join us next week where Austin Whiteley will be discussing Daikin unit ventilators, short deep dive. So please come see us next week. Thanks, everyone. Have a good day. Bye.